Hey guys, today we're going through another LeetCode question in a mock interview style. And the question we're going through today is add two numbers. So you are given two linked lists representing two non-negative numbers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. So in this example, we're given an input of 243 plus 564 and we are expected to output 708. As always, I encourage you to pause the video here and try and solve the problem on your own first. So the first step is to always ask some clarifying questions from your interviewer. For example, can the inputs be null? Can one number be larger than another? Is it possible to have one number be null and have another have a valid number? What should be returned in this case? Since this is a LeetCode question, this will not be very helpful, but in an actual interview it is essential to ask these kind of questions. Now, many of these problems are actually brain teasers that you'd easily be able to solve by hand if you forget about the code. So that's where I always start. So for this example, let's just work through the addition. I know we know the addition, but it's helpful just to work through it to get your mind thinking about how we can solve this problem. So let's write out the two numbers we have here. So we have 342 plus 465. Okay, so to start we know that 5 plus 2 is going to equal 7. There we go. Now 6 plus 4 we know is going to equal 10. So when we do this, we put in the 0 and we carry the 1 up top for the next number as our carryover digit. And then we know that 3 plus 4 equals 7 plus 1, the carryover digit, will equal 8. And there we go. That's how we get our solution. So the digits are being stored in reverse order, and this is actually beneficial for us because that's exactly how we do addition anyways. However, just from running through this example, we can see that the most important thing to consider in this example will be the carryover number. So what if we stored this carryover number and added it to the two digits we are currently looking at? So let's just run through an example going through more of the code side, because we're going to start looking at this data structure. So we have 2, 4, 3, and we also have 5, 6, 4. Okay, so I'm just going to do this in a format where we have like our first number plus our second number plus our carryover digit. Okay, so when we have our first two numbers, we're going to do 2 plus 5, and the carryover will be 0 off the bat. So we have 2 plus 5 plus 0, and we expect our digit to be 7. When we do our next two, we have 4 plus 6 plus 0. Now we expect our digit, in this case, to be 0 with a carryover of 1. And then in our last case, we expect to do 3 plus 4 plus 1, which equals 8 to get our number. Okay, so the question becomes, how do we extract the carryover number? This is very simple high school math. So the number mod 10 is the digit. So for example, let's say you had the number 107. So if we had 107 mod 10 would equal 7. Perfect. That's the digit we want. How do we get what the carryover is? Well, we can just do the original number divided by 10. So if we did 107 divided by 10, we know that we're going to get 10.7. However, because it's an integer, it always will round down, so it's going to actually equal 10, which is perfect because now we've separated out the digit and the carryover amount. So let's go back to our example for a second. Just delete that. So we have 2 plus 5 plus 0 equals 7. We can then do the logic we just talked about. So if we do that, the digit equals 7 mod 10, we're going to get 7. The carryover will equal 7 over 10, and because it's going to be an integer, it will actually equal 0, which is exactly what we're looking for. Then we would increment the pointers and look at the next two digits. So we have 4 plus 6 plus 0 equals 10. So our digit is going to equal 10 mod 10, which equals 0, and that's perfect. And our carryover is going to equal 10 over 10, which equals 1. Fantastic. And then for our last digit, we're going to do 3 plus 4 plus 1, which is our carryover, equals 8. And our digit will equal 8 mod 10, which will equal 8. And our carryover will equal 8 over 10, which will equal 0. So our final answer will come out to be 7, 0, 8. Great. So what if one number was larger than the other? Well, we have to keep going with the rest of that number and carry over then. The same thing goes if we finish both numbers and we still have a carryover, we still need to insert this into our answer. So we're going to have to account for that when we're writing code. So let's get started on the code now. Okay, so from the question, I've copied in the object they give you, which is the list node object. Within the list node object, we have an integer value and a list node next. I've taken the liberty of creating the two example linked lists from the question. So we have the 2, 4, 3 and the 5, 6, 4. I then set a list node result equal to the result of our function. And while that result doesn't equal null, I'm just going to print out the result so we can make sure we're doing this correctly. So let's start coding this function. So the first thing we want to do is we want to create a pointer to the front of the first linked list and a pointer to the front of the second linked list. It's important to use good names in your coding, so we're just going to call this pointer 1 and pointer 2. So we have list node pointer 1 equals L1 and list node pointer 2 equals L2. Perfect. So now we're also going to create our result. So we're going to call this list node result, and we're going to set it to a new list node. We're also going to create a pointer to the front of our result. So we'll create list node result pointer equals result. You may be wondering, why would we create two? Well, we want to return the front of the list, but we're also going to want to keep track of where the end of the list is as we go through this question. Therefore, we need two list nodes. And as per how we discussed solving this problem, we're going to need a few variables. So we're going to create int sum. We'll set that to 0 initially. We're going to create int digit. And we're also going to create int carryover. Okay, so now we know we need to keep going through while either the first list node has a value, the second list node has a value, or our carryover is not 0, because that means we're going to need to insert a new digit. So we'll just create that while statement now. So while pointer 1 doesn't equal null, or pointer 2 doesn't equal null, or carryover doesn't equal 0. Okay, great. So we're going to set our sum to 0 every time it goes through this function. And now what we're going to do is we're going to say if the pointer 1 isn't null, then we need to add its value to the sum and increment it so that it goes to the next value. So if pointer1 doesn't equal null, then our sum equals the sum plus pointer1's value. Pointer1 will now be set to its next. We want to repeat this process for pointer2. So if pointer2 doesn't equal null, we're going to add to the sum the value of pointer2, and we're going to set pointer2 equal to pointer2.next. Okay, great. Now, we also, in addition to our 2 digits that we've added to the sum, we also need to add our carryover. So we need to say sum equals sum plus carryover. Okay, so as we discussed before, our digit is going to equal the sum mod 10, and our carryover is going to equal the sum over 10. Okay, perfect. So now we can set our result pointer value equal to the digit that we've just calculated. And then we need to create a new result pointer for the next, we need to create a new list node for the next part of the result pointer. So result pointer.next is going to equal a new list node. And then we're going to set result pointer to this new list node we've created. So result pointer is going to equal result pointer dot next. And at the end of all this, we're going to return our result. Okay, great. Let's try running this. So, unfortunately, we're getting an extra 0 at the front of our number that should not be there. However, there is a way to cleverly modify our solution to account for this. So what we're going to do is we're going to take these numbers, these 2 lines right here, and we're going to move them actually to the front of our code. So I'm just going to copy those out, and I'm going to paste them right here. Okay, great. So now you're probably thinking, oh no, we're going to have a 0 at the front now. This isn't a problem because instead of returning result here, we're going to return results next. That way we have no extra zeros anywhere. So let's just try running this again, and you'll see we get the correct solution. So now let's talk about some test cases we may want to run through. These will be based on how your interviewer answers some of your clarifying questions, but here are some ideas. What if one of the linked lists is null? What if both of the linked lists are null? What if the numbers are different lengths, etc.? For these, just walk through your code with an example and make sure your code still works. If your code failed any of your test cases, think how you can revise your solution to address it. Well, that's it. I'll put up the solution on GitHub for anyone to download and review. Please leave comments if you see any errors, think you have a better solution, or if you solved this in a different language and think it might be helpful for the community. And be sure to subscribe if you want to see when I put out new videos so you can solve these problems right along with me. Good luck with your interview practice!